Hey everyone, I am Rajshekhar. Welcome to another session on computer organization. In this video, we will discuss about the basics of memory system. So let's get started. So by the end of this session, you'll be able to understand what are the different types of memory in the computer. Second, how they are interconnected each other. So we will discuss about the connections. And third is we will discuss each memory type. The first type of memory in the computer to be discussed is a register. Register is actually a faster device in the computer, and then we have to discuss about the cache memory, and then main memory are also called as the RAM. Main memory, and then secondary storage, and auxiliary storage. These are the various types of memories in the computer. In the earlier video, we have seen there is an interconnection process between the devices, right? First, I have taken some hard disk. From hard disk, the data will be passed to RAM, is called a primary memory, and from the RAM to CPU. This is the general flow of operation that we discussed in the earlier video. But now we are going to add a few more memories in that. Let us see. Hard disk is a memory type that we know. From hard disk, the information is passing to RAM. Right from the RAM, the information should be passed to an extra memory called the cache memory. Whenever we are pronouncing it, we simply pronounce this as a cache. From the cache memory, the information will be passed to a CPU. CPU may contain internal components. Those components are normally called as registers. We have two types of registers here, general purpose registers and special purpose registers. We'll discuss this very soon. Let us see the connection. Right, we have a hard disk. Whatever the program that you save in the computer, that will be saved in the hard disk. From the hard disk, whenever you try to run that program, that will be passed to the RAM for the execution. RAM will store that information and that will be passed to the CPU. This is what we discussed in the earlier session. But now I would like to introduce another memory called the cache memory. What is the purpose of this cache memory in between RAM and CPU? Let us understand this more in detail. We have a RAM. RAM contains both the instructions and data. In between, we have an extra memory called the cache memory, and then CPU. If you see this entire hierarchy, there is a RAM and CPU. In between, we have a cache memory. Whenever the CPU wants to execute a few set of instructions, it will look for the first instruction in the cache memory. If that first instruction is not available in the cache memory, the CPU will look that into the RAM. If that instruction is available in the RAM, that will be fetched and the instruction will be executed. What the cache memory purpose here? For example, here the instruction 1 is taken by the CPU from the RAM. For example, we have assume 5 instructions are here. Assume 5 instructions are in the same block of memory in the RAM. If you consider this is a block of memory, the entire block will be fetched by the cache memory. So here what cache is doing here is it is analyzing what will be the next instruction to be executed by the CPU. That will analyzed by the cache memory, and it will prefetch the entire block of memory from the RAM to the cache memory. So whenever for the second instruction, it is asking in the cache whether that is available or not. Yes, it is asking for the second instruction. In this case, the cache memory already taken all the 1 to 5 instructions. So the cache memory contains that instruction and it will send the response to the CPU. So the CPU no need to contact the RAM again, right? This is the basic process. In this case, if you say RAM is a slower memory, cache is faster memory, right? And CPU is, we already know that it is a super fast. So if you see, this is a slower memory, this is a super fast memory. There is a gap between these two. That means there is a speed gap between the two. So we use this cache memory. So in this case, what cache memory will do here? It will prefetches the instruction. We can say prefetch. In the CPU, we already know that two types of registers we have, and of course we have various other cache memories in the CPU. We will discuss that whenever discussing about each and every individual memory. But in this case, there are two types of registers that will CPU generally contains. The first type of register is called the general purpose register. General purpose registers are normally denoting as R0, R1, R2, etc. Another type of register is called the special purpose register. Special purpose registers like MAR, memory address register, which is used to hold the currently executing address, program counter, which is used to fetch the address of the next instruction to be executed by the CPU. Next we have MBR or MDR, memory buffer register or memory data register, which is used to retrieve the data from the memory. Right, this is another special purpose register. And we have another register is called the instruction register, so which is used to hold the currently executing instruction in the CPU. So these are all the various special purpose registers, R0, R1, R2, etc. These are all the general purpose registers which is used to perform a specific task in the CPU. Now let's go back to the memories again. If you see registers here, we already know that there are two types of registers here. The first type is called the general purpose register and special purpose register. Normally, the registers are used to store some intermediate values that is processed by the CPU. For example, R1 is a register. If I say R0, in this case, we can say that R0 data will be transferred to R1. We can manage that with the help of some control signal. For example, if you see P is a control signal here. So P is a control signal. Whenever the P is 1, R0 data will be transferred to R1. This is a simple instruction. We normally call this as RTL. That means register transfer language. That we will discuss whenever we are discussing about the registers more in detail. Now the cache memory. Cache memory is generally categorized into three types: L1 cache, L2 cache, and L3 cache. L1 is called the level 1 cache, L2 is level 2 cache. This third cache memory is outside of the CPU chip. L1 and L2 are on the same CPU chip for giving a better performance. So if we consider a CPU chip that we have drawn a simple diagram here, let us go back to the diagram and try to understand the same thing. For example, if you see cache memory here, if you assume this is a L3 cache, L1 cache and L2 cache will be residing in the same memory chip. But of course, there is a size restrictions. L1 is super fast in the computer. L2 is little bigger in size but less faster. But L3 is slower than L1 and L2 but the bigger in size. Let's go back again. These are the various types of cache memories. And we already know that cache memory, the basic purpose is to prefetch the instructions. Next, main memory. Main memory is called main memory. Main memory is normally built with semiconductor memories. So one of the example for this is RAM. We can also consider ROM is an example for the main memory. RAM stands for random access memory. ROM stands for read-only memory. This is normally used for BIOS operations. That means whenever you power on your computer, the instructions must have to be loaded from the ROM. And then RAM stands for random access memory, which is a volatile memory. Volatile memory is depending on the power. If there is a power in your system, the content will be preserved. If there is no power, entire content will be vanished from the RAM. But ROM is not like that. All the content in the ROM will be preserved. It is permanent. But whereas if you go for the RAM, whenever there is a power on the chip, RAM content will be available. If there is no power, there is no data. Right? That's why we call this as a volatile memory. Normally, this is also called as a dynamic RAM. Cache memory is called the static RAM. There is a difference between these two. Cache memory is faster. Main memory is actually slower than compared with the cache memory, because the cache memory is normally built with a transistors in the computer. The transistors are super fast. The dynamic memory, which is made with capacitors. And also I forget one more thing to discuss in the register. Register is actually made with flip-flops. A flip-flop is a simple cell which can hold only one bit of information, that may be either 0 or 1. So if you consider a 16-bit computer, there are 16-bit register we have here, so that it is made up of 16 flip-flops. And of course it is faster, but it is costlier. If we consider a 32-bit computer, it may contain 32 flip-flops at build width, 64 if it is a 64-bit computer. Right. If we come for the secondary storage is normally considered as a hard disk drive. Hard disk drive, we already know that, right? There are lots of information will be stored in the hard disk. The size is too much bigger. That means it will be available in terabytes of storage. If you consider 1 TB hard disk, for example, 1 TB hard disk size cost maybe 5K. Same, if you go for the main memory cost for 8 GB itself, they might charge you 5K. It is 1000 GB, but here only 8 GB. So there is a lot of price difference. And of course, RAM is super fast, but hard disk is super slow. And the auxiliary storage. Auxiliary storage means it is a supporting storage. What do you mean by supporting storage? Let us see. Supporting memory means CDs, DVDs, Blu-rays, etc. All are come under the auxiliary memory. It is actually very cheaper than compared with the all other memories in the system. Right? Let us draw a simple memory hierarchy in the computer. We know that the fastest memory in the computer is registers. Next one is cache memory. We can also call this as a static RAM. Next, the third one is main memory, or called as the RAM. It is called a dynamic RAM. And then secondary storage, and then auxiliary memory. If you come from top to bottom, we can clearly say that the size is getting increased, right? If you go from bottom to top, speed is getting increased, cost is getting increased. So entire memory system is completely depending on these three parameters, right? Size, speed, and cost. We may get a doubt, right? Why we need all these memories in the computer? This is one of the biggest question. So the answer is quite simple. If you go for the registers, if we use registers in the place of cache, if you use registers in the place of RAM, if you use registers in the place of secondary storage, or if you use registers in the place of auxiliary memory, the price will be heavy, right? We cannot bear that cost. So to balance your system so that everyone can afford it. So these three, size, speed, and cost, are the three major parameters that decides the price of your system and speed of your system. So here the size, speed, and cost are the three major parameters to be considered, right? We cannot build an entire system with registers. We cannot build an entire system with auxiliary memory, or we cannot build an entire system with the secondary storage device. It is actually not possible, right? If you take, for example, CPU is, we know that CPU is faster in the computer. But if we come with the hard disk, for example, imagine there is only CPU and hard disk in the computer, there is no other memory. So just imagine your speed of computer. It is terribly slow, right? This is one case. Imagine all our registers in the computer, there is no other memory. So imagine the price of this. We cannot bear it, right? So to balance all the three, like speed, cost, and size, we must have to depend on this memory hierarchy, right? These are all the fundamental concepts of a memory system in the computer.